Pumbing lemma for context-free language. Just like pumbing lemma for regular language, we have pumbing lemma for context-free language. This will be very clear if you watch the video pumbing lemma for regular language and then try out this one. Now, as with pumbing lemma for regular language, this pumbing lemma for context-free language is used to prove that the language is not, or to check whether the language is regular context-free language or not. It is used to prove L is not context-free language, or it is used to check whether the language is context-free language or not. It has defined a set of rules for how a context-free language to be. Suppose you are considering L as context-free language, then there is some integer n. For all strings Z belonging to capital N with the Z belongs to the language with the length of Z greater than or equal to N, you are going to divide this Z into U, V, W, X, Y for some strings U, V, W, X, Y, satisfying the condition length of UV should be strictly greater than 0, that is the length of V cannot be epsilon, does not belongs to epsilon, also X does not belongs to epsilon. There should be some symbols for V and X, and length of VWX is less than or equal to N for some I, not for some I, for all I greater than or equal to 0. If you are going to construct string U V power I W X power I Y, then it should belong to L. Only then L is context-free language. So U V pumped I times W X pumped I times Y should belong to L. If that is the case, only then we say L is context-free language. So they have defined a set of rules for how a context-free language should be. We will use this lemma to prove that L is equal to A power n, B power n, C power n such that n greater than or equal to 1 is not regular. So what is the first step we'll be doing? We are going to use prove by contradiction method. So we will assume L is context-free language. L is context-free language. Now you have to select a string Z belonging to L with the condition that length of Z should be strictly greater than or equal to n, and Z should be divided into strings U, V, W, X and Y. So we will be selecting, let our Z be A power n, B power n, C power n. We can very well select this as A power n, B power n, C power n because it satisfies the condition that the length of the n should be greater than or equal to n. Here our length is 3n. Now we need to divide this Z into U, V, W, X, Y with the condition that length of U and X should be strictly greater than 0 and length of Vx is strictly greater than 0 and length of Vwx should be strictly less than or equal to n. So with these two conditions satisfying, we can divide this x. So let me take my length of U and UVW to be A power n and remaining x, y to be B power n, C power n. Okay, so what will be my U? Let it be y because this V also I am considering 3A's, W also I am considering some 3A's here. And let my x is equal to some 3B's. So my y is going to be B power n minus 3 C power n. So what is the length of Vx here? It is equal to 6 greater than 0. I can select like this. Okay, definitely my length of VWX is going to be less than or equal to n, because I am taking my VWX in few counts. Okay, now I need to select a value of m in such a manner that when we are going to pump u v power, uh, I'm sorry, I'm using another variable name. So let it be. If I'm going to select my I have to select my value of I in such a manner such that u v pumped I times w x pumped I times y should not belong to L. So I'll be selecting my value of I as 2. So what is your u? A power n minus 3. What is your v? 3 v's. So pumped will be 2 times. So a power 6. Again a power 3. And again a b power 6 for x power I. Okay, x is going to be 3 b's. And it is pumped twice. So b power 6. B power n minus 3. So this is going to be a power n plus 6 again c power n. B power n minus 3 c power n. This is not belonging to L definitely. There lies a contradiction in our assumption. So L is not context free language. So similar manner you can try one more problem and show that L is equal to a power I square such that I greater than or equal to 1 is not context free language. You can try in similar manner and try to prove this language is not context free language. So this video will be very clear if you first watch Pumbing Lemma for regular language and then watch this video. Thank you.